Okay.
Might want to make a piece that provides a wall. It goes like this and fastens into here.
So that wall goes back toward the ball. Oh, I see. Because otherwise you can see in there.
1.843.
1.843 as it sits on the table.
As it sits on the table for me.
Okay. Okay.
Oh,
I see.
To work on the inside, and I'd rather not have to take the whole thing.
The whole shell. Got it. Okay, so keep it as half shells.
Do 135 and then turn 180?
No, I think 90. In other words, there's no problem with the arm sticking out this way. The shoulder joint will allow it to rotate.
Yeah, 135 degrees. No, wait a minute. Okay, I'm confused. All right,
But when the robot's arm is sticking straight forward, then you can't move. You don't have this degree of rotation, which is a rotation basically taking place in this part of the arm. It's sticking out. When it's sticking out like that, it can rotate around here. This whole thing can rotate. But when it's sticking out over here, then this rotation gives you this, but you can't do this.
Okay.
You can't
Could you go ahead and turn it here first and bend it around?
Well, what it needs is a rotation between the elbow and here. It needs something to rotate in here.
Yeah, because once you turn that, Mike, show them what happens. Once you turn this to turn this, now your orientation for this joint. Can you illustrate that? You know what I'm saying? Like right now. Yes, Mike, right now you can rotate that like you said.
Turn
around.
it down and then bend it on around.
No, but see the problem is once you rotate this to a given angle, now this thing is going to be like wanting to do like this or some arbitrary thing because you can't just freely rotate this to the position you want because when you do that, this whole assembly rotates and it's fixing the angle. Like right now it's ready to rotate in a horizontal plane.
I got you.
But yeah, we rotate it like 90 degrees, now it's in a vertical plane.
Okay.
That's the arm hanging down.
Right.
Arm sticking out to the front. An arm
That's a little bigger.
sticking straight up. Moving arm straight out.
Where do you buy your hardware from?
Speak.
Tetrahydrofurane.
Okay, that's a good safe solvent
yeah.
if you can get it. Okay. And you say that works on stuff like PVC and
Plastic, yeah, pretty much any kind of plastic I've ever tried except polyethylene. It may work on polyethylene, I don't know.
which nothing seems to work on polyethylene, is that right? Right.
This yellow, that's
Okay.
the upper arm, and this is the lower arm fully
bent.
back, and this sticking out straight. This is the 5-inch or 5 1/4 diameter I was talking about. That's a cylinder that's the same width as the
small.
as the big tube.
Here's an approximation of Will's proposed elbow joint. Straight down up to about 135 degrees. Maybe we can kind of get an arm in the picture, sort of ish. Let's see.
Yeah.
You got to do that.
Got to be below the hip, yeah.
Okay, how about around there? Does that look about kind of consistent with?
My wrist is just about on my hip.
You're short.
Yeah.
I'm sure. I got a long.
Well, that's
short.
keep in mind, if we take 4 inches off this, it's going to look a little different. So maybe if the hand can be somewhere in there, would we say that's, we can always lengthen or shorten this a little bit.